Hi, welcome to this lesson on Euclidean geometry, similarity and congruency. Let's have a look at question 5. P, Q, S, and T are points on the circumference of the circle, and TS is produced to V, so that SV equals 2TS. Okay, so PQ, S, and T, these are points on the circumference of the circle. And then this line chord TS is then produced further out to meet at the point V outside the circle. And we're given that SV is 2 times the length of TS. So if I let this TS length equal X, then SV must be 2 amounts of X. Okay, so the total length of the line VT is 2X plus X is 3X. We're also told that TRQ, so this chord here, is produced further out to the point U, such that when you join U and V together, it is parallel to SRP. Okay, so the first question is to prove that TR over TU equals 1 over 3. So again, whenever we ask to prove some sort of proportionality, we need to find the relevant triangles, and then either use similarity or the proportionality theorems if they are parallel lines. Now, because we have been given parallel lines, it's best to look for triangles that have those parallel lines and then use the proportionality theorem. Okay, so I see TR, which is this length here, and then I see TU, which is this entire length here. So because I look at this larger triangle TUV, I can see that this line SR and VU are parallel to each other. So I can use the proportionality theorem. So I can say that TR over TU is going to be in the same proportion as TS over TV. Okay, and the reasoning there is prop theorem, the proportionality theorem in triangle TUV. And that's because SR is parallel to UV. Okay, so how does that help us? Well, we know that TS, we let that equal X, and TV was X plus 2X, which was 3X. So X will divide into here because it's a non-zero number, it's a length. So that'll be 1 over 3, right? Because that's 1 times X. And that's exactly what we wanted to prove. All right, so the reasoning here was proportionality theorem in that triangle TUV because the lines SR and VU were parallel. Next, we want to show that triangle TQV is similar to triangle PSV. So again, we can either do it by showing all the relevant sides are in proportion, or by showing the angles are equal. Okay, so again, we don't know too much information about side lengths other than the proportionalities we were given. Okay, so I'm going to use angle, angle, angle as my approach here. So I need to show that angle T equals angle P, angle Q equals angle S, and angle V equals angle V. Okay, so triangle TQV, let's take that out of the diagram and analyze some of the properties. So there's TQV. And then triangle PSV is going to be this one here, PSV. Okay, well, first of all, V is a common angle to itself. So I'm going to note that. So I'm going to say, yeah, in my proof, that angle QVT is equal to angle PVS, and that is because they are a common angle. Common angles are equal to each other. Okay, so the goal here is then to show that angle P is equal to angle T and angle Q is equal to angle S. Okay, so let's have a look where these angles are. Okay, so angle Q is this one here, right? And angle S is this one here. So we want to show that those two angles are equal to each other. All right, so first of all, let's note something here. Look at this circle and the points on the circumference, right? If I look at point Q and point S, that arc subtends to P and it subtends to T. So we can say that these two angles here are equal. Okay, so I'm going to note that down. I'm going to say angle QPS. Okay, so this angle here is equal to angle QTS. And that is by angles subtended by equal arc. And that equal arc is QS. Okay. And then also, if you look at the points P and T, they make another arc, and they subtend to Q and S on the circumference of the circle. So therefore, these two angles must also be equal. All right. So I can say then that angle PQT is equal to angle PST. And again, same reasoning. Angles subtended by equal arc, and that arc in this case is PT now. Okay, so far we're just putting some information on the diagram that might be able to help us. Okay, so have we got any angles now that can relate to these two triangles that we are trying to show that are similar? Okay, so if I look at this triangle VPS here, I see that one here, okay, and then I see in triangle QVT that this is also equal here. Okay, so I've shown that angle P equals angle T here. All right, so we've got that information listed down here. So angle T equals angle P, it's this one here. So because I have two angles that are equal to each other, this third angle by default needs to be equal by sum of angles in triangle. So I can say, therefore, angle VQT must equal angle VSP by angles in a triangle. Okay, this triangle, both angles, right, have to be equal, because when you sum all the respective angles, it must give you 180 degrees for both triangles. All right, so what have we shown? We've shown that this angle V is equal to itself, this one here, okay? We've shown that angle P equals angle T, and then lastly, by angles in triangle, angle Q equals angle S. So therefore, I can claim that triangle TQV is similar to triangle PSV by angle, angle, angle. Okay, all of these questions that require showing similarity is always about looking at all the information that's given to you and then putting in angles and seeing which angles match up to help you prove that. Okay, the next question is to show that QV times PV equals 6 times TS all squared. So again, whenever you're given questions like this, when you want to show some sort of equality, it's usually to do with some sort of similarity that you've proven. Okay, so let's go ahead and prove this. So we've shown already, right, in the previous question, that triangle TQV is similar to triangle PSV. Okay, so let's go ahead and use the sides that are going to help us answer this question. Okay, so I see there's a QV there, there's a TS there, there's a PV there. Okay, so I need to look for those sides. So I'm going to take this relation. I'm going to say QV, because that's the one I'm looking for. And then TS is this part here. We called it X and 2X. Because it's on the larger line TV, I'm going to use TV here as my second proportion. So I go in the exact same sequence. It's going to be SV and PV. So I can say by these triangles being similar that QV divided by TV is in the same proportion as SV over PV. Okay, so it almost looks like it's going to match up now. So if I cross multiply both sides, QV times PV, which is great, that's what we wanted on the left, equals SV times TV. So not quite this expression just yet, but let's carry on. So we got QV times PV equals, well, SV, that was 2 amounts of ST. Okay, so I'm going to rewrite SV, okay, it's this information here, as 2TS. And then TV was 3 amounts of TS. Okay, 3x. So 2 times 3, those are the like terms, gives you 6. And TS times TS, those are the like terms, will give you TS squared. And that is how we would prove this equality. Okay, so whenever you ask these types of questions, we want to show some sort of equality. It usually has to do with some sort of similarity that we've just proven. Okay. Lastly, we want to show this long string of similarity here. Yeah, we are showing 3 triangles are similar. So let's break them out. Triangle UQV is this one here. then triangle RQP is this one here, R, Q, and P, and then triangle RST is that one below it, angle RST. So look at the order that it's written. We want to show that angle U equals angle R equals angle R, angle Q equals angle Q equals angle S, and angle V equals angle P equals angle T in those respective triangles. So let's do it one by one first. Okay, let's look at this angle Q here. Alright, so I'm going to say in that triangle, VUQ, so here's my proof. I'm going to use angle, angle, angle for each of them. VUQ, that angle is equal to angle PRQ. So where am I getting that reasoning? Okay, that is coming from alternate angles, because VU is parallel to SP. Okay, so between these parallel lines here, where's PRQ? It's this angle here. Okay, so you can see that VU and SP are parallel, and the transversal line is this line here, UR. So these are alternate angles. Okay, so those are equal to each other. And furthermore, angle SRT must be equal to angle PRQ. That is by vertically opposite angles. So where's angle SRT? It's this one here. And that must equal angle PRQ, which is this one here. So those are vertically opposite angles. Okay, so what have we actually shown? We've shown that in triangle UQV, this angle here, U, is equal to angle R in triangle RQP, so this angle here. And we've shown that that angle is equal to this angle here by vertically opposite angles. So we've shown the first case, angle U equals angle R equals angle R in those three respective triangles. So let's go for the next one. We need to show angle Q, Q, and S are equal in those respective triangles. Okay, so now we note that angle UQV, this is one we're interested in, is equal to angle RQP, and that is by vertically opposite angles again. So let's have a look where that is on the diagram. So angle UQV is this one here, and that's equal to angle RQP, which is this one here. So those are vertically opposite angles. All right, so I've shown that this angle here is equal to that angle here. And lastly, I need to show that it's also equal to angle S in the triangle RST diagram. Okay, but that is true because, so I can say now also angle PQT, that must be equal to angle PST. Okay, this one here. And that is because it's angles subtended by the same arc, PT. Right? That arc PT subtends to Q and it subtends to S. Okay, so therefore, I have shown that those two angles are equal. And that's all you really need is two out of the three angles in that same sequence equal, because then lastly, we can conclude that angle UVQ, okay, the very last angle, UVQ, this one here, is equal to angle RPQ, this one here, and that's equal to angle RTS, this one here, and that is by angles in a triangle. All right, so this angle here must be equal to that angle here, that angle there. All right, so therefore, by angle, 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 we've shown that those three triangles in that exact sequence are proportion, or not proportion, they are similar to each other using angle, angle, angle. All right, so that's how we would do this type of question. I'll see you in the next one.